In this video, we will discuss what is IOC and why do we need it. Now, IOC stands for inversion of control. When we talk about software programs have logic and logic have flow. For example, you can see over here, I have a very simple customer class here, and this customer class is invoked from the static void main function. So if you closely see the flow of this customer object, it is as follows. So for example, if I put a debug point here and let's see that how this customer object actually flows, or how does the logic of this customer object actually works. So the first thing is the console application creates the object of the customer. The customer class goes and instantiates the data access layer. So you can see here, as soon as the static void main creates the object of customer, the first thing is he goes and creates the object of data access layer, that is the SQL Server data access layer, right? After that, we call the add method of the customer, right? And the customer add method first goes and calls the validate method, and then once the validation is successful, he goes and he calls the data access layer add method. So in short, what we can say is, first the SQL Server data access layer is created, the object is created. After that, the validate method is called, and then the add method is called. In other words, the customer class is in control of his flow. Now let us go and complicate the situation. Let's say we have different flavors of data access layer. Let's say we have SQL Server data access layer and we have Oracle data access layer. So the best way to implement this scenario is, the first thing is we'll go ahead and we'll create a very simple interface here, and this interface we will term it as data access layer. And this interface will have a very simple method here called as add, and both our SQL Server class as well as our Oracle class will implement this interface, right? So you can see that I have created this data access layer here, and then I have SQL Server class implementing the IDAL. In the same way, I will have an Oracle class, and this Oracle class will also implement data access layer, right? And implement interface, right? Now the customer class, rather than pointing towards SQL Server and Oracle classes, what he can do is he can just go and use this data access layer, so that on runtime it can either point towards SQL Server or it can either point towards Oracle. In other words, runtime polymorphism, right? So you can see here I've said data access layer. Now it can point towards SQL Server or it can point towards Oracle. Now definitely we would like this data access layer object creation to be parameterized, or we would like it to be configurable. So somewhere probably from a config file, or probably by some parameter, we would like to create the object of SQL Server, or we would like to create the object of Oracle. So what I'll do for now is, I like to keep things simple here. So what I'll do is I'll create a parameterized constructor here for this customer class, and in this parameterized constructor I will take a DAL type. So if the DAL type is, let's say 1, he will go and create the SQL Server object, and if the DAL type is 2, he will go and create the Oracle object. So here I will say if DAL type is equal to 1, then create SQL Server object, right? Or else go and create a Oracle object. Now the client who is consuming this customer object, or I'll say for now the console application who is consuming this customer object, need to pass here that does he want to create an SQL Server object or does he want to create an Oracle object. Okay, so for now I'll just go and pass 1. So 1 means SQL Server, right? So if you analyze the flow now, so let's say if I go and start this program in a debug mode, so the first thing what happens, the static void main creates the customer object, right? And he passes the DAL type, and the customer object then, depending on the DAL type, creates either a SQL Server object or it either creates an Oracle object. So you can see now, because the DAL type is 1, he goes and he creates a SQL Server object. After that, the validate method is called, and then the add method is called of the data access layer. So in simple words, the flow looks something like this. So first the customer object is created, then depending on the DAL type which is passed from the client, he will either create the object of SQL Server or he will either create the object of Oracle. Afterwards, he will call the validate method and then he will go and call the add method. Now the question here is, this decision making of creating the object, is this the work of the customer object? Is this what the customer object is supposed to do? And if you think logically, the answer is no. The customer object should validate the customer. That's right. The customer object should call the add method. That is also his work. But definitely creation of the object of data access layer or the decision making of the object of which data access layer to be created is not the work of the customer object. In simple words, the customer object is loaded with too much work. A good code is that code which takes care of its own logic rather than overloading with logic which he is not concerned with. For instance, in this case, the customer class is now taking care of logics like deciding which data access layer object to be created, which is actually not his work. This makes the customer class tightly coupled to the data access layer changes. And second, in long run, this code becomes difficult to maintain. So the solution here, what is the solution here? The solution here is the customer class should perform his own concerned logic like validating the customer class, calling the add method of the data access layer. But deciding which data access layer to create is not his part. So in short, this decision making of which data access layer to be created, has to be given to someone else. In other words, this responsibility or this control has to be inverted from the customer class to some external entity. So to achieve the same, let's go and make some code modification. So the first thing what I'll do here is I'll get rid of this if condition from here because this is not the customer class responsibility, right? And I'll say that, okay, the external entity, can you pass me the data access layer object from here? And I as a customer object will only reference to the abstraction that is IDAL, that is the interface. So over here what I'll do is I'll say here that whatever object is passed to me, I will just go and start using the object. So now as a customer class, I'm not concerned that if you're passing here SQL Server or if you're passing here Oracle. And that thing, I have left it to the external entity, what he wants to do. So in other words, now the customer class will only do his work. He will only call the validate method and he will only call the add method. So now the client who is consuming this customer class is responsible to pass the SQL Server object or the Oracle object. So you can see now I shifted the customer responsibility to the external entity, that is static void main, or to the console application. This is termed as IOC, that is inversion of control. So now it is the work of the client, or I'll say the invoker, or I'll say the static void main, to decide which data access layer object has to be passed. And if you visualize this scenario more carefully, the customer class now takes care of his own logic, and the unconcerned logic, that is deciding which data access layer has to be created, is now passed to the external entity. This is termed as inversion of control. In other words, the control or the logic which is not the part of that entity is taken care by someone else. And also, if you put in other terms, the flow of customer class is now affected by the external entities depending on whether they inject SQL Server object or Oracle object. This statement is very important, which I just said now. The flow of the customer class is now affected by external entities, depending on whether they inject SQL Server or Oracle. In other words, the control is now inverted to the external entity. This is termed as IOC, or inversion of control. So the benefit of inversion of control is that basically you get a more decoupled system. So in other words, if something changes in the data access layer, your customer class does not have to get affected, and something if changes in the customer class, the data access layer object does not have to get affected, and that makes your code more maintainable. Now the above way of sending an abstraction from a constructor is termed as dependency injection. But inversion of control can be implemented by various ways. You can use dependency injection, the one way which I have showed now. You can use delegates, you can use events, you can use service locator. So in short, this word inversion of control is a general parent term, while the other things, like dependency injection or delegates and events, these are nothing but the way to implement IOC. So in the coming up videos, we'll see that, how we can use this various ways of implementing IOC. So I hope that you enjoyed this video. In this video, we were trying to understand what exactly is IOC and what are the benefits of using IOC. Thank you so much.